So now we're jumping ahead to section 1.5 to explore something called a function inverse. So here's the content for finding the inverse algebraically. First, I want to make sure you guys recognize the notation. We use f of x to describe a function, and when you see f to the negative 1 of x, that will indicate that we're talking about the inverse of that function. And it doesn't have to be the letter f. You could use g of x and g inverse of x, or h of x, h inverse of x, etc. One of the trickiest things about this is we learned earlier that negative exponents usually indicate the reciprocal. This is an exception to that rule. So here, whenever you see the function with the negative exponent in between the variable and the name of the function, that's not going to indicate the reciprocal. You're not flipping something upside down in this case. It's unfortunate that they use the same symbol of a negative exponent. This case will always indicate the inverse, the opposite function. So to find the inverse algebraically, you're just going to literally switch wherever the x's and the y's are in your function. Don't move anything else. Don't move any of the exponents or the constants. Nothing moves except the letters. Wherever you have an x, write a y, and wherever you have a y, write an x. So that's your first step. Your second step is just to solve the equation for y. It's the same solving operation you have been doing from Algebra 1. You're just going to use opposite operations until you get y by itself. Now, separately, some questions may ask you to find the domain of the inverse function. This is a little different than you might expect because you can't just look at the inverse function after you find it and then identify where is the denominator 0 and where is the inside of a radical negative. For this, you actually need to look at the range of the original function. So the easiest way to do this is to graph it in some way and then identify what heights is the graph not able to reach. Is there a horizontal asymptote, for example? Or if it's a parabola like y equals x squared, we know that it has a lowest point that it hits of 0. So identify the range of that original function, probably from the graph using Desmos graphing calculator, for example, and then that will be the domain of the inverse. So here we have an example asking us to find f inverse, since they say find a formula for f to the negative 1, and they've given us the original function is 3x minus 6. Now remember, f of x, you can think of that as y. So think of it as y equals 3x minus 6 for a second. So the first step I gave you for finding the inverse is to switch x and y. So I'm going to write x equals 3y minus 6. Notice nothing got moved. I still have 3 times the variable minus 6. I just changed what variable is there. So every time you see a y, write an x. Every time you see an x, write a y instead. That was our first step. Our second step is to now solve this equation for y. So following order of operations kind of backwards basically, I'm going to add 6 to both sides. And then I would divide everything by 3. So the other side's going to end up being x plus 6 all over 3 equals y. Once you have solved the flipped equation for y, that is your inverse. So I would now write my answer as something like f to the negative 1 of x equals x plus 6 over 3. So that is our inverse function. Now the second part is going to ask us to find the domain of f inverse. So again, I'm not going to look at my domain restrictions from this. Otherwise, I would see that it's just all real numbers. For this, you have to be a little more careful, and you need to plug in your original function. So in this case, y equals 3x minus 6. So I'm going to show you what that graph looks like. Here's the graph of the original function, y equals 3x minus 6. Remember, when using Desmos graphing calculator, you don't have to type the y equals part. You can just type whatever's on the other side of that equal symbol. So here's the function. Now, this one was a pretty straightforward example. You can see that the graph actually goes up and down forever. So if I was to define the range on this, then I would see that my y value can go from negative infinity to positive infinity, which means my domain is also going to be negative infinity to positive infinity in this case. But always just draw the graph of the original function, look at what y values your graph is hitting. Sometimes you might need to zoom around or move the graph to find exactly the highest or lowest point, and then use those values as your domain. So now coming back to fill in our answer, I can say that the domain of f inverse is going to be negative infinity to infinity. Here's another similar looking example, but this one will illustrate the problems with our domain a little bit better. So for this one, we are still asked to find the formula for f inverse, and we've been given y equals square root of x minus 5. So my first step to find the inverse, I'm going to flip the variables and say x equals the square root of y minus 5. So there's our step 1. Step 2, now I need to solve this equation for y, so I need to get it by itself. I have a square root going over this entire expression, y minus 5, so if I square both sides to get rid of that, I will now have x squared equals y minus 5. And then one last step, the opposite of subtracting 5 is adding 5, so now I can say x squared plus 5 equals y, which means my inverse function is x squared plus 5. So this is the expression that would work backwards. If I plug a number into this original equation, it'll spit out an answer. If I take that answer and plug it into this equation, it'll take me back to the original number. So now we need to find the domain again. So let's look back at the graph, because if I look at this function, I would think that there's no problem. There's no domain restriction. It's negative infinity to infinity because I don't have any square roots and I don't have any fractions that make the bottom 0. But by looking at the graph, we're going to get a different answer here. So here you can see our original function. Again, make sure you plug in the original and not the inverse that we found. So the original function was y equals square root of x minus 5. And by looking at this graph, I can see that there is a lowest point that it hits. In fact, you can even click and it'll show you that 5, 0 is dot on the graph. So you can place along, if you actually click with the mouse, it will tell you the coordinates that you're looking at a given point. So our lowest height in this example is 0. So my range would be from 0 with a bracket on it all the way to infinity, because this graph seems to be going up forever. Not very quickly, but it does seem to be going up forever. There's no asymptote or anything that's stopping it. So that range is what's going to define the domain of our new function. So when I'm writing my answer for this, I will have to specify that the domain is actually bracket 0 to infinity. And that's why we have to go through that process of graphing, because if I was just looking at the inverse here, I would not have found that restriction. I would have thought it could be any number imaginable. So there are some inherited restrictions, they're often called, from the original function when you find the inverse. And the best way I find to identify those is to look at the range of the original function, and then the range of the original function is the domain of the new function, and vice versa. If you're ever asked to find the range of the inverse, it would be the domain of the original function. So that's all for the notes on this section. Thanks, guys.